Okay, how are things? Just a little video on some financial maths for higher level leaving cert, some of it also applicable to ordinary level. Probably the first thing to look at, just to understand how interest is working, is what it means to increase a quantity by a percentage. So you have a certain quantity Q0 somehow standing for starting, and it is increased by a certain percentage to Q1. And before financial maths came on the scene, you would get 1% of this, multiply it by whatever. If it was 6%, you'd multiply it by 6, and then you add it to this to get this. But it's kind of a long way, not necessary. What is a lot better is something like this. Your new quantity, or the new value of the quantity or whatever, is equal to the previous value plus the increase, which I'm writing as delta Q, just a change in the quantity. Now the way we set this up is the percentage change, or the percentage increase, or the change, is given as a percentage of the original. And this is why, for example, unless there's something else kind of given, usually a percentage change is given the change over the original rather than the change over the new. So the change is some percentage, which I'm going to call I here, of the original. And here you just have a little bit of algebra. You take out the common factor of Q0, you're left with 1 plus I. So to increase something by I%, or not quite I%, but by I as a percentage, so I is percentage increase, e.g. we'll do a little e.g. in a second. I might have to go off and grab my calculator anyway. You multiply by 1 plus I. So for example, at some stage, I think when I was younger, maybe something like $8.60 was the minimum wage. And I think when you were you didn't actually get that minimum wage. It was $8.65. You didn't get that minimum wage until you were 19. I think at the age of 18 you were given, I'll just put the $8.65, you were given 90% of it. But say for example, someone said, we're going to increase the minimum wage by 15%, you can multiply it by 1 plus 0.15. There is now a button on the calculator where you can actually write 15%, but it's probably better to do this. So for example, to increase 8.65 by 15%, you just multiply by 1.15. Handy enough. We get equals €9.94 and 3/4 of a cent, which I'll just leave there for the moment. Okay, so that's the first thing. That's how you increase something by percentage. You multiply it by 1 plus I. Now interest is done in the same way. So for example, if you lodge a certain amount, or invest is the language they often use, principal, and suppose you have interest, yearly interest, for example, of I, then how do you apply the interest? Well, the interest is you're adding on a certain percentage, so you're multiplying by 1 plus I. So if we say that maybe at the very start you have P, and now we're just going to lodge P. We're just going to leave it there. We are not going to save regularly. This is all we're going to do. Now after year 1, well, there's going to be interest. How do you do interest? You multiply by 1 plus I. Okay. And then in year 2, well, what happens? Well, you basically increase it by I again. So you multiply by 1 plus I again. And of course this is 1 plus I squared. And if you, for example here, if you look at the interest here, the interest after 1 year is I times P. Now here the interest is not twice this, because of course you get interest on the interest, and this is compound interest. So the interest in after 2 years, or yeah, I'm going to do it after 2 years, you get interest on this twice, but you also get interest on this. You also get interest on the interest. So you get this kind of thing. And if you keep doing this, after n years, you have the initial amount and interest has been applied n times. Now this is a general formula for actually if you invest P at rate I over n, what I might call interest periods. Now in this question, the way it's set up, well, the way I've kind of given it, the interest period is a year, but it could be a month, it could be a week, or it could be a day. Typically you're talking about a month, although it could be 3 months or something like that. And then the value of the investment is the initial amount, and the interest has been applied n times. So this is a formula that you do see in your tables. And this is really the basics, and it's the background for all of these questions that we're going to look at. Okay, the next thing we're going to look at is APR. So now there's various different ways of explaining this, but probably the best is to talk about, I say you have ARRR, it should be APR. The best way is probably talking about it is a normal current account. Now the interest on a current account is very, very small, but if you imagine it, say on January 1st, we'll say 2018, to, I'm going to have a sneeze now in a second. December 31st, 2018. Now they might advertise that, and again it's actually probably even smaller than this, but say if they said we have an interest rate of 1% per annum. Now what this really means is that if you have €100 put in on January 1st, that at the end of the year they'll give you the 1% on it, and you'll have €101. Happy days. Now that isn't exactly how they do it, because say if you threw in €100 here, I mean, when do they apply the interest? Is it on December 31st, where your €100 is sitting there all year? It's equal to €100, and then they give you the €1. Well, if that was the way they did it, what you could do is something like this. You can chuck in a couple of euros here for whatever, for the crack, and then blah blah blah. You're not, you don't really need anything. And then December, around Christmas time, borrow a lot of money and get as much money as you can. You can even borrow it at 0.5%. For example, if you could borrow €10,000, well, 1% of that would be €100. So if the interest was given on this day, borrow the 10,000, interest of €100, and give the €10,000 and €50 back, and keep €50 for yourself. That's obviously not the way they do it. Now, I'm not actually sure 100% how they actually do it, but a reasonable way for them to do it is to kind of average the amount of money you have over the year. Is at the close of business, is what they should do is give you 1% divided by 365 per day. So basically they average out the 1% over the 365 days. Now the thing about this is, now this is a very, and it could even do 365 and a quarter, but we won't bother with that. If you actually look at this figure, it's very, very small. It's approximately, I'm coming out something like 0.0002740. Now this guy is 1%. This is a tenth of a cent. This is 1/100%. So this is 2/1000ths, if I'm not mistaken, of a percent. So this is really, really small. So I said this would be 1%, 10 to 100. It's 1,000. So it's about 3/1000ths of 1%. So it's very, very small. Okay, very, very small. For example, if you had 10,000 euros, if I'm not mistaken, no, 100,000 euros, this would give you 3 euros. So it's very, very small. So 100,000 euros, you only get 3 euros, but that's per day. And what happens with that 100,000 euros is you get 3 euros on the first day, and then in the second day you get your 3 euros again on the first 100,000, but you get interest on the interest. Now this percentage of 3 euros is tiny, but there's 365 days, so it's going to build up to a degree. Now, I won't write down 100,000, but imagine if you just invested a certain amount P. Now what you're going to do is you're going to apply the interest, this interest here, 365 times. Now 1% is 0.01 over 365 to the power of 365. Now this probably won't be, now there should be interest in the interest, so this should be a little bit bigger than 1%. So this to the power of 365, it's a tiny bit bigger, but it is bigger. So to 4 decimal places, or I might have to take a few more, 0.1005 basically. So it's a little bit more. So 1% compounded daily is equivalent to 1.005%, and this yoke here is called the APR, the annual percentage rate. In other contexts it might be called the annual equivalent rate. Typically with larger percentages it gets a little bit more exaggerated. For example, 5% compounded daily is the same as 1 plus 0.05 divided by 365, all to the power of 365. This is equivalent to 5.127, for example, percent. And it becomes a bit more and more. Now, where it really starts to kind of hurt is not with savings, but with something like a credit card, where they might throw at you something like 15%. And now I'm just going to say monthly for argument's sake. And you're like, oh, that's not too bad. But actually when you do the sums, so it'd be 1 plus 0.15 divided by 12. And that to the power of 12. It's a little bit more. Okay, maybe it's not that dramatic, but it is a little bit more. So this is one thing that we have to understand. The APR is just saying, now by the way, with these, this is if you put in money and didn't actually, just stuck in money at the very start. At the end, if you got the interest on all those little days, it'd be the same as doing interest on the very last day at this amount. Okay, the formula is pretty much knocking around. I might just horse it down here. The APR is equal to 1 plus the yearly interest compounded over this many n periods, something like this. Okay, so for example 0.35 monthly is going to be 1 plus now this is a different thing, because this is saying it's 0.35% per month. This is not like taking the 10% and dividing it by 12. This is actually giving the 0.35% monthly. It's explained a bit more in the actual question if you want to have a look at it. Now, one thing, 0.35 is less than 1, and if I have 0.1, that's 1%, so this will have to be smaller than that. If you're ever kind of totally spooked out, you are allowed to use 0.35. There's a percentage and a good Casio calculator if you want to do it. So this to the power of 12, go at it there, 1.0035 power of 12, coming in as 1.0428 18007. I'm not always exactly sure, I can't remember what the question said. A good question should say to so many significant figures. For me, 4 significant figures is a good thing. Now this is, remember, 1 plus the interest, so this is like 1 plus 0.042818, so on and so forth. If I'm going to take the first 4 significant figures, well, first, there's not even a first, 4 significant figures, you basically go until you get something non-zero, that'll be the 4, and then after that take 3 more figures, 2, 8, 1, but the 1 gets rounded up by that. Okay. Now this other question is a little bit harder. So here you're getting 4.282 is 0.35% monthly. Now this is going to be a little bit more. Now we have an unknown, call it something. Now you can call it X, but you should be getting a bit better. You don't have to use X, grow up a bit. Use something else, so let I be the monthly rate. I'm having fierce trouble with the H's. And what you want is, if you apply this monthly rate 12 times, that this is exactly the same as doing 1 plus 4.5%, which would be 1.045. Right, you have a little algebra problem here. That's how you should attack it. Work from the outside. What's the opposite of to the power of 12? Well, like the opposite of, or the inverse of squaring is square rooting. The inverse of the power of 12 is the 12th root. So we have 1 plus the interest is the 12th root of 1.045. And now just, you want to get I on its own, take away that 1. Get an exact answer of 12th root of 1.045, take away 1, and sure we'll approximate to all 4 significant figures using the calculator. 12th root 1.045 minus 1 is coming in at 0.00367, and I want one more. Now I have 4, 8, so the 8 rounds up the 4 to a 5, which as a percentage is less than 1%. It's 0.3675%, and as we said, should have been a little bit more than the 0.35. So there's APR little questions that can be popping about. Understand, this is probably actually a better picture. This is a kind of a strange situation. This isn't the normal situation. In fact, this isn't even not the normal situation. The normal situation is that you have a certain percentage divided up, and that's kind of more what you'll see in savings questions, etc. Okay, so that's your APR. What else we got here? Amortization. Now I have a formula here, but it needs to be probably explained a little bit more, and we'll probably do this in here. So basically what you have here is money that you get in the present. So P, I won't write present value or something, but it's money in the present. And this is like, there's two big things that this is like, both of them of course are the same. The first is when you get a loan. When you get a loan, you get the money straight away in the present. So this is a loan, and actually it's a loan amount. And similarly, mortgage amount. And they're basically the same thing. The only thing you'd say about a mortgage typically is a longer term. In other words, you have longer to pay it out. The other one is that we'll look at the next page. There are different formulas. For a reason unknown to me, you're given this formula and you kind of derive the other one, which we'll see in a second. Now, sometimes I don't really know what they're doing. I don't know why they give you this formula and not the other one. They either should give you both or none of them. To derive this one is, if I recall, a little bit trickier. I think that's probably why. Because basically what you do is you say how much you owe, and you start with you owe P, but then there's interest on that. But of course the amount you owe is decreased because you're paying off, and that's what the A is. The A is the payment. Usually a monthly payment, but for a loan it could be weekly or